This is a beaker full of a little bit of liquid nitrogen. I have a helium balloon here, and it's not floating because it doesn't have much helium in it and the weight of the balloon is pulling it down. I'm also going to fill a balloon with my own breath. And then I'm going to dip the balloon in the liquid nitrogen and ask what happens to it. Shrinking. Why? Because it's cooling the air in the interior of the balloon. And in fact, it's kind of crackling and becoming that's what happens to helium. Oh, that was with air. This is with helium. It started off a little bit bigger. We're actually running a little low on liquid nitrogen there. Basically, just to show that through the ideal gas law, PV equals nRT. If the temperature is lowered inside of a balloon, either the pressure has to go down or the volume has to go down. Since we have atmospheric pressure acting on the outside, it's the pressure inside and outside has to be both have to be atmospheric pressure, then the volume has to decrease.
Let's see how big we can imagine it. Sometimes we do experiments inside. Sometimes our moms say, take it outside, boys. Come on, this one's too big. The chief scientist at the Imagination Station, Carl Nelson's here outside with something so big. What are we doing?
We're going to talk about air pressure.
Okay.
14.7 pounds per square inch on our body all the time. And what's interesting about it is if you can create a slight imbalance in air pressure, you can do some pretty amazing stuff. Okay, this is a container of liquid nitrogen. It's very, very cold, liquid nitrogen. If I put this 2-liter bottle in there just for a few seconds, hopefully we can like cool the air inside a bit. It takes up less space, and besides being very cold, the bottle now has sort of collapsed in on itself.
Yeah.
Okay, because those air molecules have condensed a bit. So I want to do this on a bigger scale with something much more interesting, like this 55-gallon drum.
Yes.
Okay. So what I'm going to do is I've added a little bit of water inside this drum, and I've heated it up a little bit ahead of time, but I'm going to add a little bit extra heat, because what I want to do is get the air inside turned in, and that water turned into water vapor, turn it into steam, get it very, very hot. And it's going to be kind of noisy.
Flame on.
Maybe.
Is this Carl's first rodeo?
No, it's not. I think I just have too much gas going in. Let me turn it down a bit.
Same for me.
There we go. Okay. So we're going to heat it up a bit. What we're looking for, Tony, is over here. We want to see steam coming out that hole. When it gets hot enough, I'm going to put a cap on. Seal it up. But first we want to get it really hot. Just hold it.
Oh, okay.
Okay, so we're going to try to cap this very quickly.
Put this down?
You can put it down, yeah. Okay. In fact, there's a wrench on the table over there, Tony. If you could bring that over.
There you go. Why do I feel like Marty McFly to your Doc Brown? Here you go, Doc.
I don't know, man. This little cap is not cooperating here.
Okay.
I don't want to strip it when we get it on there. You know what?
Yeah?
This is...
It's good. Cap locked, loaded.
Cap is there we go. We got it on.
All right.
Now hopefully we have enough of that hot air trapped inside there, because our next step is to take this barrel and to cool it quickly on that tray of ice over there, Tony.
Right.
So watch out for the liquid nitrogen. Let's pull that down. we may have to resort to that to cool things down. Come on over here and pick it up, Tony.
Okay.
And we're gonna just put it right on the tray of ice.
All right.
Watch out.
Hey.
Careful.
Right.
Okay, put it on there. Now, what we're hoping to hear are the ends popping in like a drum head. Go ahead and rotate it with me. We're gonna want to try to cool everything down as much as we can, as quickly as we can. Get that water vapor inside to condense back into liquid and to cool the air down inside. Now, we might be able to help this out a little bit, Tony, with that pitcher of water you have there. So, what you can do is we'll just like pour the water right on top. It's gonna be a little messy.
We're expecting some big things here.
You never know.
It's part of science. It's the experimentation process.
You never know.
Trial and error. Oh!
There we go. Yeah. So, that right there, look at. We crushed the 55-gallon drum, or at least got it to crush a little bit, all because of a slight imbalance in air pressure.
I'm slightly imbalanced myself. All right, well, if you want to come on down to the Imagination Station, they are open today. And if you live in Lucas County, you have a kid who lives in Lucas County, that kid 12 and under gets in free with a paid adult admission. You never know, really, what's going to happen.
You never know.
And even the scientist doesn't know.
Still crushing.
That's how you imagine it.
Hi, I'm Jared, and we're going to be doing some experiments on air pressure. It's going to go with lesson number 3. Very simple, very user-friendly. We have a very simple water bottle that's been recycled. You can see I pulled the label off just to make it easier for you to see. And you'll notice that I put food coloring in the water just so you can see it better. Normally it could be clear, and that's fine. The cap is good to go, and then I have a very simple push pin. So what we want to be sure and very clear about is that air has pressure. Air is pushing down on us every inch of our skin. Air is pushing down, but it's hard for kids to really see that. So we want to do everything we can to show kids that air pressure. And we're going to do it by creating a hole in the bottle with this pin. So I'm going to take this pin and I'm going to just simply, with the cap on, push the pin right into the bottle. And when I pull it out, you think water will come out of the hole. And let's see what happens. Nothing came out. And I'll put it back in the same hole so you can see. There's a hole there. Now when I apply pressure to the bottle, you'll see it spurt out. When I stop, nothing comes out. And the question is why? Well, the answer has to do with this cap. This cap is keeping all that air from coming in and pushing down on that liquid. So when I take the cap off, air's going to get in, and the air should be pushing down on the top of that liquid and forcing it out. So here we go. Let's take the cap off all the way, and you're going to notice I have a trickle. It's coming out on a steady flow. Air is pushing down, pushing it out the hole. So let's stop it. I'm going to cap it, seal it. It stops almost right away. No air can get down and push on that liquid. Air is pushing. All the air in this room is pushing against that hole, and it's preventing that water from coming out. Watch again. Very simple. Air pushes down on the top. It comes out the hole. Cap it. No air can get down to push on the top. Air is pushing on that hole. Nothing comes out. Air pressure. What a cool thing.